Hi everyone, in this video we're going to look at maximum and minima applications, and this is an application of calculus where you have a function and the maximum is what you're interested in because it might be to do with output, and so you want to maximize output. Or conversely, you might have a situation where you're looking at cost of an operation and you want to minimize cost. So that's an application for calculus, certainly in operations of businesses or stuff like that. So let's look at this question. A farmer has 400 metres of fencing to make a rectangular enclosure. One side of the field is alongside a straight river and does not need to be fenced. Determine the maximum possible area of the field. Okay, so let's draw out a river boundary and draw out the boundary of our fence. And we're told that it's rectangular, which means that if this side is x, then this side would have to be something that's different from x, and that side there would also be x. So that means that two lots of x plus y, if that's the distance of the fencing, would have to be equal to 400, and so that means that y would be equal to 400 minus 2x. The area of this rectangle would be base times height, so it would be xy. So if we get it just in terms of x, it would be x times, and if we substitute this into here for y, we would have 400 minus 2x. So expanding that, we would have 400x minus 2x squared. Now if we differentiate that function, we will get a place where we can find the gradient is equal to 0, and that will be the maximum area. So we'll differentiate this function with respect to x, and we'll get 400 minus 4x, and we'll set that equal to 0, and then we'll solve that for x. So 4x equals 400, and so x equals 100. So that's the distance of x in order to get maximum possible area. So that would be 100, and that would be 100, and so therefore y would be 200. So the area, we need to put that back into our original area formula, would be 400 times 100 minus 2 times 100 squared, and so the maximum possible area for this one would be 400 times 100 minus 2 times 100, just my 2, times 100 squared, 20,000. So 20,000 meters squared. Okay, so I guess with these questions, you want to formulate whatever you're looking for in some way in terms of just one variable. So that's why if you look here, we've got area in terms of x and y, but then we formulated it just in terms of x, and then we differentiated it, and by setting the derivative equal to 0, that finds us a maximum. So an x value where area is maximized, and then we substitute that value back into our function to find that maximum value. So if you follow that formula, it should be fine to complete some of these exercises in 23.05. So I'll let you start that now.